Emma, and I like ham radio. Today we're going to learn how to work with big and small numbers when we're measuring electricity.
In our previous videos, we've been talking a lot about different units of measure, like volts, amperes, and watts. But there's been a couple times where we've added something to those words. Do you remember?
Not really.
When we were talking about how much electricity most houses use, what word did we use?
Kilowatts.
Yeah, but if we measure power in watts, what's that kilo during in the front?
It means it's bigger than a regular watt.
Yeah, you're right, 1,000 times bigger. In fact, 1 kilowatt is 1,000 watts. But why did we say kilowatt instead of watt? Couldn't we just say 1,000 watts?
Well, it seems a little easier to say a smaller number.
Yeah, you got it. As numbers get bigger and bigger or smaller and smaller, it gets a bit tricky to keep track of all the digits in the number. So we add a prefix to the unit, and then we reduce the number down. So instead of saying 10,000 watts, we can just say 10 kilowatts. What about if we had 1,000 volts? How would you say that?
1 kilovolt?
You got it. In the science world, which includes electricity, we use the metric system. And one neat thing about that system is that you can use the same prefix for different units, and it works. Kilo means 1,000 for all units.
Kilowatts, kilovolts, kilograms, kilometers.
Yep, all mean 1,000. Because it's a multiple of 10, to convert one value to another, we can just move the decimal point. How many places will we move it for the kilo prefix?
3.
Yep, there's actually prefixes for quite a few stops along the way as we slide the decimal place.
There are? I just know a couple.
Well, okay, let's start with moving the decimal point one place. What is 1 with just a single 0 behind it?
10.
You're right. The prefix for one place is deca. We don't tend to use that one very often, but there is one word I can think of that uses it. What do we call 10 years?
A decade.
Right. And you can see the deca prefix on the front of it. The next place is 2 zeros. We use it even less than deca, but it's hecto, and it means 100. We already talked about the next stop, a 1 with 3 zeros after it. What's that?
Kilo.
Right. Now, after 3 places, we start jumping by 3s. There's no prefix for 4 and 5 zeros. I checked because I was curious. Next stop is 6 zeros. What number is 1 with 6 zeros behind it?
Well, after 1,000, would it be 1 million?
Yeah, the prefix for 1 million is mega. We'll be using this one a lot. Can you think of what we use a bunch in ham radio that starts with mega?
Megahertz.
Right. 1 megahertz is 1 million hertz. So what's next? If we slide 3 more places, what do we call that? I'll give you a hint. We use mega in the computer world too. In megabyte. What's bigger than a megabyte?
A gigabyte.
Right. And the prefix there is giga, which is 1 with 9 zeros behind it, or a billion. In the case of a megabyte, it means there are a billion bytes.
Whoa.
Yeah, that's a lot, isn't it? If your computer has 4 gigabytes of memory, that means there are 4,294,967,296 bytes. Isn't it a lot easier to just say 4 gigabytes?
Yeah, way easier.
After giga, we keep on going on up to tera, peta, exa, and zeta, and on. But we won't be using those prefixes much in ham radio. Those are some pretty big numbers, right? But now, okay, what if we want to talk about something smaller than 1? In English, we add a th to a number's name when it's less than 1. So 10 becomes tenth, 100 becomes hundredth. And what's next?
Millionth, billionth, trillionth, zillionth?
Zillion isn't actually a real number. So Just like we move the decimal point to the right, we can make the number bigger. To make the number bigger, we can move it to the left to make it smaller. So if we move the decimal place one spot right and got 10, what if we move it one spot to the left?
Tenth?
Yep. The prefix for tenth is deci. We'll be using that one later in this video, but for now, let's keep moving left. Next, it's centi.
Oh, like in centimeter.
Exactly. There are 100 centimeters in 1 meter. So a centimeter is 100th of a meter. Moving one more spot left, we're at 3 places. That was kilo for large numbers. What's the prefix for the opposite small number?
Milli, like milliamps.
Yeah, we mentioned that when we were using the multimeter, didn't we? Now, once we hit 3 places, we start jumping by 3 again. Next stops are micro, nano, pico, which are 6, 9, and 12 places to the left. Those are really, really small numbers.
Yeah, like teeny, teeny, tiny.
That's a lot of prefixes to remember. One way to remember them is to make a mnemonic sentence out of their first letters. For example, the great merciful king hates dogs because dogs constantly make messes, which is tera, giga, mega, kilo, hecto, deca, the base number, deci, centi, milli, and micro.
Or you can come up with your own.
Yeah, you're right. Once you have them in order, you can write the decimal places under them. 12, 9, 6, 3, 2, 1, the base number, -1, -2, -3, -6. Do you know what you can use this for?
What?
Well, let's say you wanted to convert from 1.5 amperes to milliamperes. Amperes is the base unit, so let's start from there. Milli is 3 places to the right of there, so we move the decimal place 3 places, so that becomes 1500 milliamperes.
I see. It makes it easy.
Yeah, we'll try a few more of this during quiz time, but let's tackle a more difficult topic first.
Okay, bring it on.
Okay, so when you're measuring things, you usually try and keep everything in the same kind of units. So if you're measuring an electronic circuit, you might measure everything in milliamps. But sometimes there are some times when you want to compare things that are so different in size that trying to use the same scale just doesn't work. For example, what would you use to measure the length of your pencil?
Centimeters, maybe?
Sure, and you could probably find a tape measure with centimeters marks on it. Okay, now how about if you had to measure the distance from Chicago to Los Angeles?
That would be a pretty big tape measure.
No kidding. Now imagine if you had the task of displaying both of these numbers on a meter. In science, there are 2 really common things that have measurements very far apart like that.
What are they?
Well, sound loudness and radio signal strength. For sound, it's the difference between a whisper and a bomb explosion. So scientists invented a way to describe both of these using small, simple numbers. It's called the decibel.
Oh, there's the prefix.
Good catch. You remember what deci means?
A tenth of a bell?
Yeah, a bell. A bell is a unit named in honor of Alexander Graham Bell, the man who invented the telephone. A decibel is a little different than most units because it describes a change or a difference between 2 things. Most measurement scales describe things as a distance from 0. How tall are you?
Around 4 foot.
And I'm around 6 foot. Both 4 and 6 are measured from 0. But you could also say that I'm 1.5 times as tall as you. Something that is 1.5 times as tall as me would be 9 feet. In both cases, though, you could describe the difference as 1.5 times.
Oh, okay, I see.
In decibel terms, 10 decibels describes a 10 times change. So something that is 10 times as big as another thing, 20 decibels would be 100 times, 30 decibels would be 1,000 times, and so on.
Oh, I see. You can kind of see by the number of decimals how many zeros to multiply by.
Right. Yeah, that works when we're multiplying by tens, but there are one or two really common cases that we need to remember too.
What are those?
Well, many times multiplying it by 10 is too big. A more common thing is to multiply something by 2. So common, in fact, that we have an English word for it. We can double something.
Oh, yeah, okay.
In the decibel scale, when we double something, it's 3 decibels.
3? Why 3?
Well, it's a bit advanced, but I'll give you the simplest explanation I can, and then if you want to know more, you can look it up and learn more. Deal?
Deal.
Okay, so decibels use a logarithmic scale. That's a big words, but it's not so tough to understand. Basically, we ask the question, how many times do we multiply 10 by itself to get to a particular number? So, like we talked about earlier, 10, 100, 1,000, and so on. They're really easy. So, for example, to get to 1,000, we would multiply 10 by 10 by 10. How many times was that?
3.
Right. So 3 bells, or 30 decibels. Now here's the tricky part. How many times will we multiply 10 to get to the number 2?
I can't.
Well, you can't if you're using a whole number. 10 multiplied by 0 times is 0. 10 multiplied by 1 is 10. So we need something between 0 and 1. As it turns out, the number we need is 0.3. When we convert that to decibels, by moving the decimal point, we get 3 decibels.
I didn't even know you could do that. That's awesome.
Like I said, the reason behind it is a bit advanced, but you really don't have to know that for the ham test. It's enough to remember that doubling something is 3 dB and quadrupling something is 6 dB. But did you know that the average adult probably looks at a decibel scale several times a week, possibly even several times a day?
Huh? Where?
It's right there on everyone's cell phone. Can you find it?
No, what are you talking about?
Well, it's a bit disguised. Cell phones display it as bars. You know, when you have full bars, you have a good signal, and when you have only one bar, you have terrible signal.
Oh, yeah. That's decibels?
Yeah. Yeah, actually, it's decibel-milliwatts, or dBm. Remember how decibels are the difference between two things? Well, to make them a little more useful, let's pick a specific reference point to compare everything to. In the case of decibel-milliwatts, that point is 1 milliwatt.
How does that make the bars then?
Well, okay, so when a phone is showing only 1 bar, it's actually below negative 110 decibels below 1 milliwatt.
Whoa, that's super tiny.
Yeah, that's 1 followed by 11 zeros, and that's below 1 milliwatt. That's 1 bar.
What's 5 bars then?
That's negative 50 to negative 80 decibels. Still a lot smaller than 1 milliwatt, but not nearly so bad as 1 bar is.
It's amazing cell phones can hear a signal so small.
I agree. We take such amazing technology for granted because most people don't really know what it's doing. But by learning about radio, we can really appreciate the power we hold in our hands. Speaking of hands, we'll be combining hands-on and quiz time again, as we work through some of the technician's questions on paper.
Let's get hands-on quiz time! Alright, so welcome to hands-on quiz time, and you can see we've drawn the number line. So we've got the great merciful king hates dogs because dogs constantly make messes. And so we wrote the values here. 12, 9, 6, 3, 2, 1, base number, negative 1, negative 2, negative 3, negative 6.
Yeah, and you don't always have to draw a number line here, but I thought we'd draw it so that we can kind of see which way you move the decimal place. And then once you get a hang of it, then you can kind of memorize it in your head, and you'll remember which direction you need to go.
Granted, we just made a mistake a couple minutes ago, so that's okay.
So we're going to start with a couple questions. So the first question from the test is, how many milliamperes is 1.5 amperes? So let's start by writing the number down.
All right, 1.5. There we go.
Okay. Now
Excuse my handwriting; it's not the best.
So our number is in amperes. So we're going to start from there. You want to make a mark where we're starting?
Boop.
Okay.
Just a little remember mark.
And then we're going to go to milliamperes. Where's that on the number line?
So this one's milli, this one's micro. So we make a little mark here.
And right, so we're going to go from here to there, right?
Right.
So what we're going to do is that's going to be 3 hops or 3 places. So let's move the decimal place 3 places.
So we'll make a little 1, 2, 3. And we add zeros here, so we'll rewrite our new number here. 1,500, so.
1,500 milliamperes.
Yeah.
All right, let's do the next one.
All right, we'll erase it with our.
Okay, so which of the following is equal to 500 milliwatts? Okay, so let's write down 500.
500.
And all of the answers are in watts. So we're going to start at milliwatts. Looks like we already have it marked.
Oh, yeah, that's nice.
But this time we're going to go from milliwatts, and we're going to go over to the base unit.
Here, we'll draw the decimal point on here, so. You wouldn't draw zeros after that because if you have any zeros past the decimal point, you just kind of shorten them.
Mm-hmm.
So. That's why normal numbers, you don't usually have the 0.00, however many zeros.
Okay, so if you're going to, how many hops is that? How many
So that'd be 3 hops.
Okay.
To this direction.
To the left?
To the left, yep.
Okay, go ahead and do it.
So we go 1, 2, 3. So we'll rewrite our number here as 0.5.
0.5. 0.5 watts.
Yeah. Now erase that. Next question.
Okay. What is another way to specify a radio signal of 1,500,000 hertz?
Okay, we'll write that down. So
Yeah.
how many zeros does that have?
1, comma.
1, comma, 5.
5.
I know that, but how many zeros does it have? 5?
2 zeros after the 5. Total of 5 zeros. There you go.
All right.
And so that's in
Hairy
hertz.
number there.
Yeah. Hertz is our base number, right?
So we'll write the little.
Okay.
Z, that's the
HZ,
thing for
good job.
hertz.
And we want to, what is it? So we got a couple options. We have an option in kilohertz, we have megahertz, gigahertz, and another kilohertz. So, well, let's see here. Let's look at the letter A.
Okay.
If we're going to go from hertz to kilohertz, right? So we would have to hop
3.
3. Okay, so if we move the decimal place 3 places, what would we have?
1, 2, 3. We'd have 1,500.
Oh, that looks like the answer then.
Yeah.
All right, so
Wow,
it would be.
that's pretty good luck. So we'll mark it on here.
Mm-hmm.
And then that would be 15. You can do the comma if you want to. It's not necessary. But we'll draw it in just because. There.
All right. On to the next one.
All right. Erase it. Start over again. We can even erase the little marks if we want.
Okay, so if an ammeter is calibrated in amperes, is used to measure 1,000 milliamp current, what reading would it show?
3,000.
3,000. Yep, you're right. So let's write down 3,000.
3. 1,000.
And that's milliamps. Okay.
I'm just writing the that so that we know what form it's in.
Right, so we want to go from milliamps, and it looks like all the answers are in amperes. So
So if we're going from milliamps to amperes, so amperes would be the base, milliamperes. So that means we would have to move three hops. So our decimal place is here. 1, 2, 3. Wow, hey, that leaves us with 3 amps.
Good job. That would be letter C. All right, next one.
Okay.
They're pretty easy, aren't they?
Yeah. Once you have this down, it's just like boom, boom, boom. It's really easy. I wouldn't say it's the easiest on the ham test, but it is pretty easy.
Okay, so if a frequency display calibrated in megahertz shows a reading of 3.525 megahertz, what would it show if it were calibrated in kilohertz?
3.525?
3.525, right?
525.
And this time, instead of using the base unit, we're going to go from
megahertz to kilohertz.
Right.
So we'll do megahertz to kilohertz. And we're using a dry erase marker, so I have to kind of skirt around it so I don't erase it with my hand.
And how many spaces is that?
Well, it looks like, if I did my math correctly, it'd be 3.
Okay, so what does that change to then?
So if we move it this way, right?
Yep.
Yeah. 1, 2, 3. So okay, so we'll write that as our new number. 3.525 kilohertz. There.
And that is answer number C.
Oh, good.
Good job.
All right, now we erase and start again. Next question.
Okay, so the next question is, how many microfarads are equal to 1 million picofarads?
Wait, picofarads? That's not even on our number line.
Yeah.
Yeah.
But if it were on our number line.
Let's write down a million first.
Okay.
1, 3, 6. I don't know why I said 3. 6 zeros behind it. It's a lot of zeros. But there are things that have more zeros.
Yeah.
You gotta not be scared of lots of zeros.
So, okay. So here's what we're going to do. A pico, that pico is negative 12.
Whoa. So here, we'll write it, because if we
Why
extend...
don't we continue the line down here or something so that we can see it. So just imagine that it keeps going.
Poor Pico. Keeps getting left behind.
Okay.
Nobody ever remembers it. They always stop at micro.
So
Wouldn't you be sad if you were Pico?
So what we're going to do here is we're going to go from pico, which is negative 12, and we're going to go from pico to micro. So how many spaces is that going to be?
6.
Okay. So we currently have something that is in picofarads, right?
So we'll make a little mark here.
Okay.
And then we'll make a...
And we're going to be moving how many spaces in which way?
6 spaces this way.
To the left, right?
To the left, yep. We'll make a little
I
mark.
said to the left, right? To the left, correct?
Correct. All right, so 1, 2, 3, 4, 5, 6. Hey, that leaves us a good number. So it'd be 1. And then, so the micro has this weird thing. It's actually not M.
Yeah, but we just left it M because it makes sense for our mnemonic sentence.
Right. But it's actually this weird Greek letter here.
Mm-hmm.
I believe it's called a mu.
Mm-hmm. I think so.
It's kind of weird.
But it stands for micro, and it helps to differentiate between milli and micro.
Because if you have millihertz, which you don't really often, and you have microhertz, does look exactly the same. So
Right.
they changed it, and instead of it being another M, it would be that.
Yeah.
And I'm just using hertz because I know the abbreviation
Yep.
for that. I don't know the abbreviation for everything. Like, I'm not sure what farad is.
All right. So it should be 1
One.
microfarad. Right?
Yeah, that
Good
would
job.
be number B,
B. Yep.
or letter B. All right. Then we have to erase poor Pico because it doesn't get to stay on our number line. Alrighty. Next question.
All right. So the next question is, which of the following frequencies is equal to 28,400 kilohertz? So let's write that down.
All right. 28, comma 400
And that's in kilohertz.
kilohertz. There.
Right? All right. So the first option is letter
So
A.
here, let's mark it on our number line first.
Yep. So our first option is letter A, which would be 28.4 megahertz. Is that the same as 28,400 kilohertz?
2, 3. It looks like it.
Yeah, I think you're right.
Wow.
We got lucky again. It was
Yeah.
the first answer we
So we'll
tried.
write it down. 28.4. And on the test that we're looking at, they've got zeros behind here, but you, like I said before, you can just chop these right off because they don't really, because otherwise you could have 1.0000.
Right.
It's equal to just 1.
Yep.
So we'll erase that little 1.
All right. Next one is
All right.
another frequency question.
Okay.
If a frequency display shows a reading of 2,425 megahertz,
2425.
and that's megahertz,
So mega would be that one. Yep. That.
Now, what would that be in gigahertz?
Whoa, gigahertz. So here, I'll make a little mark here, a little mark here.
All right. So now we're going to move the decimal place which way?
We're gonna move it to the left.
Yep.
And we're gonna move it 3 because 9 minus 6 is 3. So
Okay.
here's
So
our
move it.
decimal spot. So 1, 2, 3. All right. So we'll rewrite that new. I don't know why I wrote 3. Probably because we moved 3 spaces, but we'll write our new number here. 2.425
Gigahertz.
gigahertz.
All right. And that is answer letter C.
Ah, okay. Cool.
All right. Now we're
Erase it.
actually going to kind of veer away from some of these metric numbers.
Mm-hmm.
And we're going to do one easy question and one harder question.
Mm-hmm.
Okay? So what is the proper abbreviation for megahertz?
So here, let me write down the answers. It has. That's letter A, and then for B, what's B? B
There's
is
a lowercase
okay.
m and a lowercase h and a capital Z.
That's capital, by the way.
And then C is capital M,
Just a second. Capital M.
lowercase h,
I can just look at it.
and lowercase z.
I can just look at it. It's
Mhm.
okay. And then number D is hopefully you can read that.
It's okay, I can.
Okay, good.
All right, so what did we talk about? What did you say earlier about the mega prefix?
So notice on our number line, like I said earlier, that most of the larger numbers are capital. So this is a capital M.
So that means we
Because
can...
the lowercase m would be milli, I think.
Correct.
Milli. Because that's a different thing. That's mu.
Micro.
Yeah.
Um,
Well, the symbol for that is a
Yeah.
little different. It's
okay,
crazy.
so that means we can throw out 2 of our answers, right?
Yep. That means we can toss these out.
So which ones? What are we
wait.
getting rid of?
We're tossing this one and that one.
So cross out A and cross out B. Now, the last thing we have is basically whether the H is capitalized or not. So I'll give you a hint on this one. Remember
I
that
think it is.
Remember that H, Hertz, is named after a man, a person.
Right. So here,
So
let me draw it.
We usually capitalize people's names, right? Right. So which answer is it?
Well, we can cross out this one. It's
Good
D.
job. It is D. So whenever you write down megahertz, you're going to write down capital M, capital H, and then a lowercase z.
that's how you write.
Okay. Now we're going to go on to something a little bit more tricky, as we talked about.
Yep.
And if you remember the lesson,
Which I hope you do because it's still in this video. So
what is the approximate amount of change measured in decibels, or dB, of a power increase of 5 watts to 10 watts?
so 5 to 10. We don't need to add the dB.
Right.
You know it's dB.
And in this case, it's both in watts, so we don't need to worry about it.
Yeah.
Okay? So we're dealing with the same...
Watts is like that, right?
Yeah.
Yeah. Okay.
Okay, so now tell me, what's the difference? Now remember, decibels are all about change.
Yeah. So
Right?
here, just a one way to do this is you go 10 divided by 5. That is 2. And here we'll erase that seconds. But remember what we said in the video. What is doubling something in decibels?
You remembered.
Doubling something is, I don't know why it's this way. It's kind of weird.
Well, remember how we talked about, if you were to multiply something by 10,
Yeah.
right? But we can't...
It's still kind of weird, even though it makes sense, but it's still, I don't know.
So we remember that if you're doubling something, how many dB is that?
3.
3 dB. Good job.
There. Yeah. So that
Okay.
would be answer B.
Correct. Not so bad, was it?
No.
Okay. I tell you what, I had a hard time with decibels when I did my test
Yeah?
because I didn't quite understand them like I do now.
Well, I'm glad that I didn't get stuck on decibels because I had some good help.
Okay, so next one is, what is the approximate amount of change measured in decibels, or dB, of a power decrease from 12 watts to 3 watts? So 12 to 3. Okay.
Kind of smearing.
Now this time we're not doubling it, are we?
Here, so we'll do that same method we did for the last one. We'll divide it by, not dividing it by 2, dividing it by 3, because that's our other number. I just happen to know that might be 4. And so if doubling something is 3, when is quadrupling it? That's like doubling the double.
Right. So,
it'd
in English
be-
we call that quadrupling.
Yeah, it's
Right.
kind of a fancy word.
But what would that be in dB then? So
It
if
would be-
doubling something was 3,
It'd be 6 dB.
now there's one thing we're missing. Remember, we're decreasing instead of increase.
So would it be a negative change?
Correct. Negative 6 dB. And that would be answer letter
C.
C. Good job.
All right, we erase.
Yep. And then we got one more decibel to look
One more,
at.
and then we're all done. And then it's on to quiz. Oh wait, this is hands-on quiz time, isn't
Yes.
it?
Yep.
Yeah.
We're doing both of them together.
Yep.
What's the amount of change measured in decibels of a power increase from 20 watts to 200 watts?
Oh, hey, look at this. This zero here.
It's just zeros, isn't it?
Yeah.
So what's
here, we can do the same method just to keep it the same. 20. 200 divided by 20, I happen to know, is 10.
10. And so what we're looking at, our answers are either 10, 12, 18, or 28. So what do you think it is?
I think it might be 10D.
Well, then you would be
correct.
Good job.
And that would be answer A.
Hey, wasn't so hard, was it?
No.